Saxon Algebra 1, Lesson 33. 2 parts, you guys. John's so sneaky. The first one is one of my all-time favorites. We're going to talk about prime factors. John teaches this differently than I do. So if you look in the book, it doesn't look like what I do at all. I make those fabulous prime factor trees, all right? So let's just jump in, break it down. You guys, this is such a useful little calculation to be able to do, not only on paper, but you'll get to the point where you can do them really fast in your head. It helps with so many different parts of math. If you can quickly break numbers down into their prime factors to compare them and to see which factors they have in common, or maybe that they don't have anything in common at all. So this is super practical, super useful. We're gonna start with the number 80. And it says, express 80 as a product of prime factors. Okay, so this is where we draw the 2 little branches and we go, okay, think of any 2 numbers that multiply to give us 80. It doesn't matter which one, you can do anything. It'll all work out fine as long as you're working accurately. But you don't have to start at any certain place. I'm gonna go, since you're not here to choose for me, I'm gonna go with 8 times 10, because that to me is super obvious. Now I ask myself, are either of those prime numbers? No, they're composites, so I'm gonna keep going. 8 is 4 times 2. Now 2 is prime, so I circle it. And then 4 I can break down into 2 times 2, and now I've come to the end of my chain. All right, back up here, I gotta deal with this 10 now. 2 times 5, and those are both prime. So I can say that 80 is the product of these prime factors. 2 times 2 times 2 times 2 times 5, right? 1, 2, 3, 4 2s, and a 5. I could also write this as 2 to the 4th power, because this means take the number 2 and multiply it by itself 4 times. 1, 2, 3, 4 times 5. This would also be a perfectly lovely answer. John usually writes it out like this, but as long as you're careful in creating that exponent, it's fine with me if you do that. All right, let's try one more of these. 33.2. The number that we're starting with is 147. Now, shootin' chuckins, you guys, that number is a little bit trickier to find 2 factors that multiply to it. 80 was a breeze. This one's kind of a pain. So we have to use some of those tests that we've studied in the past. Is it divisible by 10? Okay, this is my thinking area. No, it doesn't end in a 0. Is it divisible by 5? No, it doesn't end in a 5 or a 0. Is it divisible by 2? No, it's not an even number, it's odd. Okay, what about 3? That's my last hope for an easy divisibility test, right? Remember, the test for 3s is you add up the digits without considering their value and just see if it equals something that will be divisible by 9. 1 plus 4 is 5, plus 7 is 12, right? 1 plus 4 plus 7 equals 12. 3 does go into 12, and if I wanted, I could even go 1 plus 2, right, and add the digits in 12. But both of these tell me that 3 will work. So I put down a 3. Now I have to figure out 3 times what equals 147, because that multiplication fact is not in my head. 3 into 1, nope. 3 into 14, yes, it's just short of 3 times 5, right? Because 3 times 5 is 15, so it must be 4. 3 times 4 is 12. I subtract, I bring down. Oh, I've got a lucky winner, don't I? 3 times 9 is 27. And so I'm done. That worked out perfectly. And so my answer over here is 49. Are either of those prime? Well, yeah, 3's prime. 49, you may recall, is 7 times 7, and those are both prime. So this one was a lot harder nut to crack in the beginning, but once we figured out this, This part went really fast. So 147, I'll write the answer down here, equals 3 times 7 times 7, or 3 times 7 squared. La la la, this is right too. All right, that's the end of this part, part A. Again, John doesn't do it like me. He gets the same answers, but he doesn't make the cute little trees. And you know, that's his loss because they're far superior to the way he does it. Trust me. All right, part B. Statements about unequal qualities. Okay, so we're going back to these word problems we've been working on, where John has these like crazy riddles about find two numbers that add to this and blah, 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 right? Now, this time, what he's done before is he's told us about two things that are equal. This time, he's going to tell us about something, and at first, it's either going to look like this. We're going to write an inequality, or it might be this way. Okay, so instead of telling us about equals, he's going to tell us about two things that are not equal. They're going to be either the first one's greater than the second, or the first one is less than the second. And what we're going to do is we're going to be given a number that will help us balance the equation. So we're going to start by writing something like this, and then we'll either add something more to the smaller side, or we'll subtract that same something more from the larger side. Okay, so we'll write an inequality, and then we'll be given a new number that will help us balance it, and we'll have to figure out how to add or subtract to make the whole thing balance out. But remember that if we add to the less side, then that would balance it. Or if we subtract from the greater side, that would balance it. So we'll go slow, we'll think these through, but this is the general strategy that we're having to develop rather than just John telling us, oh, hey, they're equal. All right, so let's go slow and figure this out. Twice a number, I'm going to show you what it actually says, and then I'm going to tell you what I'm going to hide. Twice a number is 42 less than minus 102. What I'm going to do, find the number. I'm going to hide that number that's by the less word. And I'm going to write it first as an inequality without that number. That number is our more word. Okay, so let me just write it down so I can play with this. Twice a number is 42 less than minus 102. Okay, that's the problem. Now, what has John told us? He's told us that twice a number, which I know I can write, is 2n. Now, this is the more number. This is the number that's going to help me balance it. I ignore that for now. Oh, if only I had something to cover it up with. Here's my dog's bone that happens to be nearby. That doesn't really work, does it? Dog bones don't work. Sorry, Grace. Oh, I've got the perfect thing. Okay? I'm going to ignore that more number right now, and I'm going to write an inequality based on what this tells me now. Twice a number is less than, right, minus 102. The words told me exactly what to write. Twice a number, 2n, is less than, that's this way, minus 102. Now, what that tells me is this side is smaller, this side is larger. So now, when I consider this number that's going to bring me into balance, I have two options. I can either add it to the lower side, because that'll bring it up and make it balance, or I can subtract it from the greater side, right? This sign tells me he's less, he's more. I can subtract it from the greater side, or I can add it to the lesser side. I can do it either way. Either way is right. Here's the rule I always use. Adjust the side that's on the right because you have more room to write it down. Oh, I'd love to be practical, don't you? So we know that this is already the greater side. So we're going to subtract that additional number. Right? We followed this pattern in this problem. Does that make sense? I hope it does. This is just the first one. We're going to do how many more today? Oh, 3 more. All right, now it's equal, and I just put my equal sign over the top. Once I use my balancing number, I change it to an equal sign. Now we're ready to solve it. 2n equals, let's combine like terms. That would be minus 144. Divide both sides by 2, and we get n equals minus 72. That's right. Yay. All right, let's do another one. This is our pattern. Example 33.4. 5 times a number is something, I want to write it down so you can see it. 5 times a number is 72 greater than the opposite of the number. I'm copying this out of the book, just substituting numbers in for words. Then the opposite of the number. Okay? If you're doing your homework and you have this right in front of you, you don't need to copy it over, but I want to show you what I'm doing. Okay, so 5 times a number is beep greater than the opposite of the number. I don't want to think about that number yet. That will just confuse me. First, I write the inequality. 5 times a number is greater than the opposite of the number, that's minus n. Okay, now double check this, make sure it's right. 5 times a number is greater than the opposite of the number. That's what the minus sign does. Okay, beautiful. Now, where's my balancing number? Something more, right? There it is, it's 72. Now, before I think about that, I want to think about this. Which side is bigger and which side is smaller? Greater than. So this is the larger number. This is the greater. This is the lesser. That means I need to add. If I want to adjust this side, which I always want to just fix where I have room to write, I'm going to add 72. That will make this bigger, and then that will make these equal. That's how you do it, you guys. Now, I just solve it like ordinary. Swim this little fishy over here. I still owe you a picture of my math teacher, don't I? That cancels. Divide both sides by 6. And we get n equals 12. Guess what? That's right. Happy days. Example 33.5. I'm just going to write it down. If the sum of twice a number, I'm just going to write 2n, I don't want to write twice a number all out, and minus 14 is multiplied by 2, the result is 12 greater than the opposite of the number. And I'm just gonna write that as minus n, because that's how you write opposite of a number, right? I don't necessarily need you, I think I already said this, but I'll say it again. You don't need to write this out in your homework. I'm doing it so that you can see what I'm ignoring and what I'm taking, what I'm paying attention to in these problems. But what I want you to do is read through, find out where you get to the word greater or less than, and cover up the number in front of that. That will just screw you up unless you get the rest of it right first. The sum of 2n and minus 14, okay, how do we do that? 2n minus 14, even though it says subtraction, that means adding a negative number, is multiplied by 2. Okay, that means we have to put the whole thing like that. Okay, the sum of 2n and minus 14 is multiplied by 2. The result is greater than minus n. Okay, that means this is the bigger side, this is the smaller side. If I want to adjust over here, that means I need to add the number that's hiding under there, because that will bump this side up and make them equal. Yay, there's the magic number, 12. So I'm going to add 12. You guys, this is really hard, and so it's a struggle, but I have taught this, like I said, I've been teaching algebra for 20 years. This is by far the easiest way to do it. Cover up the number, write the inequality, figure out which is bigger and which is smaller, then reveal your balancing number, your more number, and take care of that over here. All right, let's do algebra, shall we? 4n minus 28 equals minus n plus 12. We need to do some swimming. I'd like to swim this guy this way, so I'm going to add n to both sides. And that means we'll have to bring the 28 this way, which is fine. Cancel-y, cancel-y. 5n equals, oh, John, 40. Divide both sides by 5. N equals 8. And 8 is great. Good? Good, good. Okay, one last problem. Example 33.6. If you're feeling a little overwhelmed by this, a little bamboozled in the brain, yeah, this is hard. This is definitely hard. We'll be doing these for quite some time, so you'll get the feel of it a little bit more, but it's fine if it's hard right now. 5 times a number is 21 less than, I hear these words and I immediately go, don't even talk to me, 21. Get out of my face. 5n is 21 less than twice the opposite of the number. Okay, 5n is less than twice the opposite of the number. I can write that like this, right? Or if I'm feeling fancy, I can just go right to that presentation. Either of those will work for twice the opposite of the number, all right? But I still got the inequality. So now I'm ready to balance, but before I look at the number, let me stress that, you guys. It helps if you leave that number covered up until you're 100% sure of what you want to do. I go back and look at my inequalities. You're the little one. You're the big one. I want to adjust over here, so that means I need to subtract. Now I look. 21. And that makes it equal. All right? You don't have to grab a little Post-it thingy if you don't want to, but for sure I want you to just cover it up like that as you're doing the problem and getting this set up. Don't even look at that number, it'll just blow your mind until you get the inequality part right. Okay, now it's easy, right? Now we just say, all right, let's add 2n to both sides. 7n equals minus 21. N equals minus 3. And that's correct. Okay? The algebra is not the hard part. This part's super easy. It's setting it up. That is the devil. Well, I mean, that's kind of strong, isn't it? It's not evil. It's just very particular. So, good luck with these. I will see you for lesson 34. Good luck. I said good luck twice. That means you're definitely going to have good luck. Okay, bye.